Good afternoon, and welcome to today's Roads and Bridges webcast. Our topic is Leveraging Connected Worker Technology to Improve Roadway Safety, sponsored by the American Traffic Safety Services Association, aka ATSSA. I'm Ryan Curtis with Endeavor's Infrastructure Group, and I will be moderating this session. Now, before we dive into today's presentation, let me explain how you can engage with us during the webinar. If you encounter any technical issues, please type your concern into the Ask a Question box beneath the video window on your screen, and a member of our team will assist you. We also encourage you to submit your questions throughout the event. We will address as many as possible during the Q&A session after the main presentation, but please feel free to send in your questions at any time using the Ask a Question box. And lastly, please note that today's session is being recorded and will be available on the Roads and Bridges website within the next week. You will receive an email notification once the recording is live. Now, it is my pleasure to introduce our speaker. Chris Brookes is the Work Zone Delivery Engineer for the Michigan Department of Transportation, where he has worked for over 16 years. He serves on several national committees and has received multiple awards, including the 2017 ATSSA National Safety Award and the 2024 ARTBA Jake Landen Highway Safety Award. Chris, we're excited to have you with us today to cover connected worker technology and road safety. So now I'm going to go ahead and turn things over to you. Chris, the floor is yours.
Awesome. Thank you. And thank you everyone for joining us today, this afternoon, or in the morning, depending on where you're located. But with anything, before I get started, I always like to consider myself a pretty humorous person. I got 3 little ones at home. So if anyone has any little ones at home, I got a nice little opening icebreaker joke to share with you. What did one snowman say to the other snowman? And the answer to that is, smells like carrots. So with that, I'm going to cover some of the things that we're doing in Michigan today, doing that. But in starting off, why? Why are we here? Why are we talking about this? Why is this important? This picture of a screenshot of a video is from a recent crash that we had just the other day, and that crash caused for 3 people on the roadway to lose their 3 Lansing people lose their life, 4 people total, and about 17 serious injuries that occurred. What this was just a standard utility crossing. So they were running a utility line across the freeway, doing intermittent stoppages on the freeway, and a semi-truck driving on the roadway was not aware of the stoppage and plowed in, and it was a massive multi-car crash. These articles and these things like this are what keeps me up at night, because I think this stuff is not 100. It's preventable. We can do better. I think we can do more. I don't want to say I hope we can get to 0, but there are steps that we can take now with technology that's available to try to minimize or lessen the severity of these. Are we going to prevent everything? Is this technology going to work flawlessly and be 100% effective right off the bat? No, but it definitely is a step in the right direction. And some of the things that we're doing here in Michigan will help really highlight why hopefully we won't have to have any more of articles like this. Or even just recently, 4 days after that, we had a roadway worker that was struck and killed in kind of a similar situation where they were out there doing more of a mobile operation. And he was out laying out flares for that, and a motorist went around the TMA trucks that were out there to go around, and was not aware that that was out there because there wasn't anything necessarily notifying them, because it was a mobile operation, pretty quick, going to be quick and get in, get out, and he drove around there and struck the worker. So, and unfortunately that worker lost their lives. So what are we doing, and how are we looking at fixing this, and what are we leveraging? What technology is out there? So today, that's what I'm going to talk to you about, but just wanted to set the stage of, this is near and dear. This is affecting all of us. I'm sure everyone, in your local areas has those stories, but here today, hopefully we'll let you take away some solutions or some upcoming technology that will really help drive that needle and help us reach the towards 0 deaths goal that we all should have on all of our roadways. So the 2 things that I'm going to focus on first are a couple of grants that we have. These are commercial motor vehicle grants, and we have 2 projects that MDOT has won. There is one that is called Safe Zone, which was a 2021 grant, and then Pause, which was a 2022. And what these are focusing on different types of work zone operations and really notifying CMV or commercial motor vehicle trucks approaching those active work areas and alerting them and motorists to what is upcoming. Safe zone is focusing more on our static work zones, and pause is focusing more on our mobile operations. But I'm going to play a short video here that'll do a nice job of kind of highlighting all the testing and everything that's gone into this, and really recapping and setting the stage for why these grants are going to be effective and what they're hopefully going to accomplish. So with that, I'll go ahead and have the video queued up for that, please.
Commercial motor vehicle crashes accounted for 41,854 incidents on Michigan roadways from 2017 to 2019, resulting in 283 deaths and 893 serious injuries. Of those, 1,739 occurred in work zones, including 15 fatalities and 31 serious injuries. The Michigan Department of Transportation recognized this serious problem, and in 2021 received a grant from FMCSA to deploy advanced work zone technology with the goal of reducing such crashes. Using roadside video analytics, smart work zone devices, and vehicle-to-everything communications, this technology will alert commercial vehicle operators to changing work zone conditions, such as the presence of workers, approaching lane closures, and the formation of queues. Deploying this technology using mobile solar-powered trailers means no existing roadside infrastructure is necessary, and the system can be easily recalibrated as worker crews move throughout the course of construction. Calibrating the system is as easy as drawing shapes on paper, with notifications activating based on object motion or presence in defined alert zones. Conflicting objects or areas that should not trigger alerts can also be easily masked out to avoid unnecessary false alarms. Having multiple cameras on each trailer means multiple viewpoints are possible, maximizing coverage. Once the cameras are calibrated, they detect and track the movement of objects, including being able to distinguish personnel from vehicles. Each detected object has GPS, speed, and heading information calculated by the camera based on its position and movement relative to the camera. Object data is then fed to a small computer in the trailer's cabinet enclosure, which processes the detected object information and generates connected vehicle messages. These messages then get broadcast by a roadside unit radio installed on the trailer mast. Such messages can be received by devices called onboard units installed in participating fleet and freight partner vehicles on the project, or any other equipped vehicles that may traverse the work zone, producing in-cab alerts and notifications about work zone conditions and objects. Personal safety messages are produced by the system for all detected personnel. Basic safety messages are produced for all detected vehicles. Personnel that leave a protected area, such as by walking outside of a temporary concrete barrier or operating in a lane closure only protected by barrels, will trigger special traveler information messages that warn operators of unprotected workers.
Look out for workers.
These messages will enable the equipped commercial motor vehicles to see and display the presence of those objects and greatly increase operator awareness of their surroundings. Other components of the system produce messages as well. Smart work zone devices integrated with cloud software will also detect the formation of queues and the activation of lane closure arrow boards. This information will generate traveler information messages produced by MDOT's back-office connected vehicle ATMS and broadcasted through the trailer radios, warning operators of upcoming queues or of the need to merge lanes. Passively, the vehicles themselves will be able to identify the upcoming work zone and notify operators that they will soon need to decrease their speed. Connected vehicle technology has been proven already through countless demonstrations and proofs of concept. MDOT's project pairs this established technology with new and upcoming tech, like advanced video analytics, to show the incredible flexibility and versatility of this technology. Achieving Vision Zero will require creative and innovative solutions to protect our most vulnerable road users and solve our most challenging use cases. MDOT hopes that through this deployment, the commercial motor vehicle industry will recognize the immense benefits, encourage adoption, and hasten its deployment, both in vehicles and as a standard component of work zone traffic control.
All right, thank you. So going through in some of the questions that we talked to you guys about, we asked if everyone was aware of the Work Zone Data Exchange, or WZDX. And there was a number of people that actually weren't aware of that. So what this slide is going to do, it's going to kind of get into how some of that architecture works. But overall, the best way that I can describe the Work Zone Data Exchange, or WZDX, in a quick, short version, to kind of, the way I explain it to, someone not in the industry per se, is that it basically is creating a language that can communicate different aspects of work zones in a uniform manner. So that way, doesn't depend on who's creating that data. As long as it's in that correct format, that language is the same across the board, so everyone can interpret that the same. So kind of how the system works, just a brief overview, is we have our smart devices that are in the field. Those would then go up to a third-party system, come into our back office, and then the WZDX feed would go out, and that would go out to your Hustler, your MyDrives, your Waze applications, whatever you're using. But then within that, we're also taking into account some of our video analytics, as you saw in there, and different things that are going on in that project. We're also taking in information from PCMS boards, stop traffic advisory messages, those queue detections, and then we're looking at broadcasting that from either roadside units to the onboard units in the vehicles if they have those installed, or going just to someone's infotainment or navigation devices if they're up. So that's kind of the flow of the information, and then basically how this is going off. This is going through mostly LTE, 5G, different services that are going out there. So just to kind of show how this is processing and what's happening kind of behind the scenes, is it's really taking this information in, going to a data aggregator, then being published there for anyone to really take and get that data, and it's in that uniform standard. So whether it's Google or Waze or any other TomTom type devices that are grabbing that information, it's in a standard format, so that way it can all be interpreted the same. So there's a multitude of vendors and everyone that can do this, and that is up to speed on that. So that is something that you'll probably hear more and more and discuss, but there was enough people that said they weren't aware of that, so wanted to take some time and explain that. So what have we done in Michigan? So we have done a couple different pilot projects. I'm going to focus with you on some that are looking at the identifying worker locations and identifying where workers are located on the roadway via some different types of technology. I'm going to get into that a little bit and kind of what we've done, what we've seen, some lessons learned. So basically, this is what we were seeing. This is one of our first early tests that we did. This was on in the Novi area on I-96 out of the kind of in the Brighton Novi area. Basically, what we did is we worked with GM and a couple of different manufacturers, and we actually had a worker out there. Myself actually was wearing the vest in the rain, and what we had is we had a GM vehicle that was modified just a little bit to have their dashboard upgraded to have the HDMI display. And then basically as that driver was driving through multiple times and giving different people rides, that would come up on their dashboard and it would say worker located ahead. So the story about that is I was sitting out there, what was happening, and after about 4 or 5 times going through, and also this was like 2021-ish time frame, so we were still abiding by COVID, so everyone had to wear masks. You could only have so many people in the vehicle, so there was a multitude of trips. Well, standing out there in the rain on the side of the road, I kind of got a little bored, so I switched spots. And actually, the driver of the vehicle was the same person driving the whole time. And he said that he could actually see my location of the worker actually move from the left side of the road to the right side. So he was aware that I had moved, and I didn't tell anyone that I was doing that, and it showed up. And that was a pretty cool feature that was available and could be done in any 2018 model year and newer for GM cars, and then there's a lot of other cars that can take that technology in today. But what we did in the fall of 2023 is one that I really want to focus on, and this is really getting into something that MDOT does, specifically in Michigan. And I know not all states have these types of speed limits, but in Michigan, our normal speed limit on a roadway is normally most of the time, most of our freeways are 70. We have a couple at 70 miles, 5 miles per hour. But the way we post our work zone speed limits traditionally is with a reduction to 60 and then 45 where workers are present. There's always a big discussion on what is actually where workers present mean, and when do you slow down and when you're not. So in lieu of trying to increase our compliance and actually slow people down going through the work zone, we took this pilot as a chance to do that. So our goal was to really reduce the speeds overall and really get a more uniform speed through that work zone, and really only tell people when they needed to go slow. So it was about a 5-mile closure, multiple weeks. I'm doing concrete patchwork, so very high exposure level for workers. It was just drums closing it. This is a picture from that actual work zone. So what we did is we had digital speed limit displays that were set up on the project. And so what we were expecting and the way it was programmed is if a worker was in between two speed limit signs or digital speed limit signs, the sign upstream would then turn to 45 and have flashing lights on it. If after they exited that, like in this section, the second sign would say 45 workers present, and then the other two signs would say 60. And then in the third scenario, the first two would be 60, with the third sign being 45 workers present. And in the fourth scenario, the first and the third would be 45 workers present. And then the middle one would be 60 because there would be a stretch where there weren't any workers present. So we wanted people to not and then travel. So we wanted to have those be accurate and up to date and really changing in real time. So one thing that we realized in doing some pilot tests with just digital speed limits before this is who's going to change those? We had a project where we tried to do this manually without sensors and technology. And what we found is that there was a very low level of compliance. It wasn't on the top of the priority list for things to get done, so it often got missed. One of the other things that we had to talk about and discuss is what is the latency and how long do we want to have a worker in each segment before it turns off once they leave that area? How fast does it turn back to do that? Because we didn't want the speed limits flickering back and forth. So we looked at some of those things. I'll talk to about some of those points in our lessons learned. And then two, one of the things that we wanted to make sure we documented was what the speed limit said, when they said it, and then how we were doing that. So that way, if there was a ticket, this would be enforceable and held up because that would be what was actually posted on the sign at that time. So those are some of the things that we were trying to solve with this project. With every good pilot project, you learn lessons as you go. So as you can see here, this picture, we have our workers right here. We have that sign that says 60 miles per hour. And what we realized is when we did this, the sensor technology was still being developed. It's a lot more further along now. So not every worker was able to have a sensor. And what happened was the roller had the sensor on it. And since it hadn't yet passed that sign, that had not switched yet. And that's myself actually walking out there to figure out if they had their sensors on, trying to do that. And so what we realized is that the sensor just hadn't passed. So that's one thing that we're working on too is, do we need some sort of forward thinking, if you're within a range of that, in front of that, does that need to change? But the other aspect is if every worker had a sensor on them, that probably would have changed that sign. But here's what it looked like once that roller got right past there. 40 switched to 45 and the flashing lights came on as they were working. So you can just kind of see how that layout works when they're right there. It makes a lot of sense. There were other times though when we were out there and we had this coming up and then you couldn't actually see the workers, but they were just downstream. So we did have the speed wizard out there, which gives you also the speed feedback of the vehicles driving through there leading into the work zone. So really we're trying to really get that compliance. So in doing that, those were kind of how we had it set up, what we were doing, what we were thinking. And really it was an awesome experience. It was an awesome pilot project. We got a whole bunch of information. We learned a lot. Definitely some things that we need to work on and refine. And that's kind of where I'm going to focus my time, but just wanted to set the stage and kind of let you guys know what we did, what we were trying to accomplish. So kind of going to get into the lessons learned here. So one thing that we did is we made sure we had that historic log, and the system that we were utilizing did log those automated speed limit changes. So that's something that was documented. This is just a sample of the feed when we were testing that. Obviously, that would be 60 and 45, but this was just one of the sample screenshots that I had of how this was going to come across. So that did work well in this project. We were able to track those and see when those changes came through and have that documented in that historic value. One thing that we ran into was, the GPS location and the refresh rate. So if you've ever had your phone, or you've ever been, looking for walking directions, or been somewhere, when you pull your GPS up, if you have an iPhone, I'll just explain that because that's what I have. The dot it's the blue dot, and then that circle gets big, and then it gets smaller and smaller, and kind of narrows you in and really locates you. When you're doing that, it's pinging your GPS location, and it's kind of mapping you. Well, what we realized is in some of our testing, I walked like 2 steps past a sign and waited, and it didn't change. And then I walked 2 more steps and it didn't change. And then sometimes it would be 5 minutes, and then all of a sudden it would just change. So what we looked at is the way that the GPS was set up in the devices is that it wasn't actually taking the point location. It was taking kind of that average location of where you had been and factoring that in. So we really needed to make sure that refresh rate was using more of a survey grade GPS point location, and not kind of that average location that a lot of the technology is commonly set up to use, because it's more where you've been, where you're going in that path versus where you are at that instant in time. And we did update that, and that was looking at being updated and pinged about once every minute is what we kind of settled on, for that to be kind of that rate of, okay, we need to have the battery life, yet we need to have accuracy of your location and know where people are. And we figured that was a pretty good setup to how that really played out, and that gave us a pretty good capture of what was going on. So on this project, we were only working in one location. So we were working on the eastbound side of the freeway. There was a shoulder closure on westbound, but there was no actual production work going on there. But as you know, workers, as they are working, most of the time there is foremen or other type of inspectors that travel on both sides of the roadway. So once you go through eastbound to come back westbound, what we realized is that there was times where the individuals that were driving back on westbound were actually setting the sensors off on eastbound, because we didn't limit the field of where that signal was coming in from. So in the future, making sure that your GPS location and your accuracy is limited to the roadbed you're on, only in that direction if you're working on both sides, is definitely some of the kind of things that you need to be aware of. Also, too, if someone was driving through the project, did they set that off if they were going through? So really, a lot of these things were coming down to determining what was the optimal lifespan, what was the maintenance threshold that we wanted to have, how long would a vest need to last before it needed to be charged, things like that, because the more you ping that vest, the more the GPS and that signal and that sensor is being pinged for location, the less the lifespan. So we tried to come up with that 1 minute, because that would allow for about a week's worth of work. So you figured if you worked Monday through Saturday, and then on Saturday you threw your vest in the charger, charged it all day Sunday, came back to work the next week, you would be ready to go. So that's kind of how we looked at that to make sure that we were within that time frame. And then one of the things and questions I get asked quite a bit is, well, did this work, and why were we even testing this? Do you think it would work? We had actually a SWISD report, or a Smart Work Zone Data Initiative, which is a pooled fun work zone group out of Iowa with about 13 states that are in there, mostly in the Midwest. And there was a recent report that it will be coming out soon, or that's already been posted, that has, we did some testing with the digital speed limit signs with that 45 being posted. But we made sure when we were testing that it was done accurately. That was kind of that first test project that led us to this. And we got some really good results with vehicles slowing down and people actually respecting that speed limit. We still have a lot more to do. We still have to figure out, okay, when this alert goes into the vehicle, when do we alert them? How long does that alert come through? What does it look like? What's the intensity? Is it a haptic seat vibration or is it something else? And a lot of the auto manufacturers are now working on that. And then two, we've kind of looked at solving this a little bit, but in transit workers, so if you're going to or from a job site, there's now a speed element that's attached to the sensor. So if you're going over a certain speed, that would then get pulled out of that system. But here is an example of how the system works in a Chrysler Jeep Stellantis, and that going through. And basically, this was a real project that went on. They had a sensor out there. They drove by, this came through their dash, and then it notified the driver, caution, vehicle nearby. And that was just through their Uconnect in their system. So with that, I know I only have a short time, but once again, the reason we're doing these is to keep all of our workers and motorists and everyone off of national memorials like this and to lead towards zero deaths. So with that, we'll go and look at opening it back up to the Q&A.
Awesome. Well, Chris, thank you so much. We appreciate you sharing that insightful presentation with us today. Now, we have received several questions, so we're going to dive right into the Q&A. And once again, if you would like to submit a question, simply type it into the Ask a Question box and hit send. So the first question is, how does the system communicate with the work zone devices, such as cones, etc.?
Yep, so that's done through the traffic control vendor or the supplier software. So basically, that sensor was talking to those devices, and that was changing those based upon communication between those two over LTE, just cellular service.
Okay. Is there a small wearable device that can act like a beacon to alert drivers on their mobile devices of the presence of a worker?
So that's where we started. We started with that, but what we found in some of our initial pilots before we got to this is that people would forget to check in and check out of the work zone or leave it on, and it would be on at the end of the day when they ended up at home. So that's why we felt like putting something on their device and not on their phone was the more appropriate way to go.
Perfect. What do you think the biggest hurdle is to moving this technology forward?
I think one of the biggest hurdles is just, buy-in from the industry and buy-in from contractors and the collective group of all of us to kind of put away or put aside the, this is watching where I'm at. Sometimes people bring up the big brother, well, I don't want everyone to know what I'm doing. But really, it's putting some of that stuff away for the means of safety. These are not identifiable points. They're not tied to an individual worker. But really doing that, and then two, bringing the automotive companies around to make this a future requirement, similar to, I compare it to seatbelts. Back in the day, seatbelts weren't required. As soon as they were, the safety and compliance of that, not 100%, but wearing your seatbelt saves your life. Having something like this required for workers that are out on the roadway can really lead to saving a lot of lives and doing that. And I think that's the biggest hurdle, is just getting that industry buy-in of this technology does work and it is making a difference. And I think we'll get there, but it's just that startup stages, and getting past that is the biggest hurdle right now, in my opinion.
Perfect. Are there any other benefits besides safety that you could see coming out of having this information?
Yeah, I think there's a lot of different things that DOTs and project personnel are required to track. So, if you think of having the information of who's on site for wage rate interviews, wage compliance, what equipment is out there, and having all that be automatically populated by leveraging what's in these devices and the technology that's out there, I really think a lot of that manual labor that's taking place could really free that up from the inspectors that are out there, and really increase the accuracy and the viability of that data and who's out there every day knowing what's going on.
Perfect. Awesome. Well, unfortunately, it looks like we've run out of time. So for those questions we didn't have time to answer, we'll be getting back to you via email. And that concludes today's webcast. On behalf of Roads and Bridges, I'd like to thank Chris for sharing that great presentation with us, ATSSA for sponsoring today's event, and of course, all of you for joining. We hope you have a great rest of the day.
Thank you, and go Lions.